Good morning, everybody. I'm sorry that I can't be in school today. I'm hoping to be back tomorrow. But I wanted to teach you lesson 6, which is synthetic division. So please take out your notes packet and turn to lesson 6. And I want you to take a minute to try example 1. So please pause the video and give the first part of example 1 a try. Okay, so you were asked to evaluate j of 1. Let's just make this a little bigger here. So what that means to do is to replace every x with a negative 1. When you type this into your calculator, you want to type it in one long string, just like it's shown here. So when you evaluate j of negative 1, you should get back a 0. So now you have to explain, and that means using words, what your answer tells you about x plus 1 as a factor. So you want to think about, well, let's get a different color here. The relationship between x plus 1 and when x equals negative 1, right? If I took this x plus 1, I set it equal to 0, and I solved, I would get x equals negative 1. So if you think back to the remainder theorem, when you evaluate the 0 of the divisor, so if I plug negative 1 into my function, which is the 0 of the divisor of x plus 1, and I get back a 0, that tells me that x plus 1 is a factor of j of x. So x plus 1 is a factor of j of x. And it said explain, so now I need a because. J of negative 1 equals 0. You also could have said because there's no remainder. Okay. Let's take a look at the second part. Now, before we do that, I want you to just think about this example. Remember back to middle school, let's say when we had the number 100, and we broke it into a factor tree. If I gave you that one factor of 100 was 2, how could you figure out the other factor, or the number that would go here? Wouldn't you take 100 and divide it by 2 to get 50? And then, if you wanted to break 50 down, you had a 2 here, you would take 50 and divide it by 2 and get 25. And then 25 isn't divisible by 2, but it's divisible by 5. So I could take 25 and divide it by 5, and I would get 5. Now, it's a similar idea here with polynomials. If we know that x plus 1 is a factor of j of x, we can divide by x plus 1 to find the remaining factors. Just like when we were looking over here, if we knew that 2 was a factor of 100, we could take 100 and divide it by 2 to get 50. Now, you have a choice here. You could either use synthetic division or you could use long division in order to algebraically determine the remaining factors. So I want you to pause the video here for a second and either use synthetic division or long division and come up with your answer. Okay, so I'm just going to show you, let's get rid of this here so we have more space. synthetic division first. So if we're using synthetic division, we use the 0 of the divisor, which in this case is going to be -1. That doesn't look very straight, but I guess it's okay. Now I'm going to take the coefficients of my polynomial and list them here. So I have a 2x to the 4th, -1x to the 3rd, -35x squared, 16x, and 48. Okay. Now I'm going to start my synthetic division. To start my synthetic division, I'm going to bring down my first term, which is a 2. Now I'm going to multiply this 2 by -1 to get -2. Then I'm going to add. -1 plus -2 is -3. Now I'm going to multiply the -3 by the -1 to get 3. Now I'm going to add. -35 plus 3 is -32. I'm going to multiply the -32 by -1 to get 32. Now I'm going to add to get 48. Now I'm going to multiply 48 by -1 to get -48. I'm going to add, and I get 0. And if this was a degree 4 polynomial, then we know we start with 1 degree less. So this is 2x to the 3rd minus 3x squared minus 32x plus 48, remainder 0. You also could have come up with this quotient by using long division. If you used long division, my divisor was x plus 1. My polynomial, or that I'm dividing into, or my dividend, we call it, right, is 2x to the 4th minus x to the 3rd minus 35x squared plus 16x plus 48. So I would take my first term of 2x to the 4th, and I would divide it by x, and I get 2x to the 3rd. Now I'm going to multiply back. So 2x to the 3rd times x is 2x to the 4th. 2x to the 3rd times 1 is 2x to the 3rd. And now I'm going to change both signs, and I'm going to add up and down. First term crosses out here, and I get -3x to the 3rd. I'm going to bring down this -35x squared. Now I'm going to take my first term of -3x to the 3rd and divide it by x, and I get -3x squared. I'm going to multiply back, so -3x squared times x is -3x to the 3rd. -3x squared times 1 is -3x squared. Change both of my signs. And I end up with -32x squared. Bring down the 16x. I'm going to take my first term of -32x squared, divide it by x. I get -32x. I multiply back. -32x times x is x squared. -32x times 1 is -32x. Change my signs. And I get 48x. I'm going to bring down this 48. And I'm going to take my first term of 48x, divide it by x, and I get 48. I multiply back. 48 times x is 48x. 48 times 1 is 48. Change my signs. And I get a remainder of 0. Okay, now you can see that synthetic division is a lot quicker and there is less room for error. So I would really suggest that given the choice that you try synthetic division. Okay, so now we have to take a look at this and say, well, we know x plus 1 is a factor, and we know this polynomial that we got here, or here, depending on how you did the problem, is also a factor. So I'm just going to write that out to start. I'm running out of space. It's writing too big on my iPad. So let's see if I can squeeze it in here. So we have x plus 1 is a factor, and this 2x to the third minus 3x squared minus 32x plus 48 is a factor. Now, can we factor this expression anymore? Well, let's see. Can we factor this by grouping? I'm going to take 2x to the third minus 3x squared, negative 32x plus 48. See if I can factor it. So here there'd be a GCF of x squared. So this would be 2x minus 3. And here there'd be a GCF of negative 16. So this would be 2x minus 3. So I've got x squared minus 16 times 2x minus 3. And x squared minus 16 can be factored further by dots. And they called this polynomial j of x. So I'm going to say these would be the factors of j of x. So you might say to me, well, what's the point of using synthetic division or long division? Why didn't we just factor the polynomial j of x originally? So if you look back up to this polynomial j of x here, there are 5 terms. So we wouldn't be able to easily factor it by grouping. So because we knew x plus 1 was a factor, if we use synthetic division or long division to divide by that factor, our hope is that we would get a polynomial that we then could factor further. So if we look at this polynomial here, right, or here, we now have 4 terms and we're able to successfully factor it by grouping. So if you're given a polynomial that you originally are unable to factor and you know one of its factors, you want to divide by that factor and hope that you can factor further after that. Okay, let's look at example 2. We're algebraically asked to factor z of x completely. And we have a problem because we don't know the coefficient of the x squared term. Right, so before we can even start, we need to figure that out. But we do know that z of negative 5 equals 0. Whoops. So that means when x equals negative 5, my y value equals 0. So for z of x, I'm going to plug in a 0. And anywhere I see an x in this polynomial, here, here, and here, I'm going to plug in a negative 5. I'm just going to rewrite what that would look like. So 0 equals 6 times negative 5 to the third plus negative 5 squared minus 52 times negative 5 plus 15. So pause the video for a second and figure out what your b value is. This value right here. Okay, let's see if we can figure this out. So we have 0 equals 6 times negative 5 to the third. So 6 times negative 5 to the third is negative 750. So we have negative 750 plus b times negative 5 squared. So negative 5 squared is 25. So I'm just going to write this as 25b. And then we have negative 52 times negative 5 would give me a positive 260 plus 15. So now I have some like terms I can combine. Negative 750, 260, and 15. So negative 750, negative 750 plus 260 plus 15. Get negative 475. So 0 equals negative 475 plus 25b. So I'm going to move the negative 475 to the other side. and we get 475 equals 25b. We divide by 25. So let's see, what would that give me? 475 divided by 25, 19. So we did all that work just to figure out what this b value is. So now we know that b is 19. So I could rewrite this polynomial now as z of x equals 6x to the third plus 19x squared minus 52x plus 15. Okay. Now we need to algebraically determine its factors. So I do have 4 terms here. So I want to look at this and I want to say, you know what? Let's see. Could we, let me change my color here. I don't have very many choices. Oops. Could we factor this by grouping? So if I thought I could, I'm going to try it, right? I could take out an x squared, and this would be 6x plus 19. And then here, ooh, it doesn't look like they have anything in common. So I could only take out like a -1, and then this would be 52x minus 15. I'd fail with factoring by grouping there, right? So that's not going to work even though we do have 4 terms. So I have to go back to the drawing board and I have to say, you know what? Let's see if I have any other information from the problem that I can use. So they told me here that z of -5 equals 0. So that means when I plug in -5 for x, I get back a 0 for y. So if I know that's true, I need to work backwards. And I have to say, okay, well, if z of -5 equals 0, that tells me that x plus 5 is a factor of z of x. So if I know that x plus 5 is a factor of z of x, I can either use synthetic division or long division to try to knock the degree of this polynomial down by 1 and see if I can factor it. Okay, so I'm going to start with synthetic division. So if we use synthetic division, use the 0 of the polynomial, which is -5. And then I'm going to put my coefficients down: 6, 19, -52, and 15. So I'm going to bring down the 6. 6 times -5 is -30. And if I add up and down, I get -11. -11 times -5 is 55. Add up and down, I get 3. And 3 times -5 is -15. And I add up and down, get 0. And if this were a 3rd degree polynomial here, that means I would have a 2nd degree polynomial here. So to start, so I have 6x squared minus 11x plus 3, and my remainder is 0. I should get the same thing if I were to use long division. And remember, when you use long division, you use the factor, not the 0. Oh, get this to move again. This is annoying that that's right there. I'll move this up. So I get 6x to the third plus 19x squared minus 52x plus 15. Okay, so I'm going to take my first term of 6x to the third and divide it by x. And when I do that, do my work off to the side here, I get 6x squared. I'm going to multiply back. 6x squared times x is 6x to the third. 6x squared times 5 is 30x squared. Change my signs. I get -11x squared. Bring down the -52x. I'm going to take -11x squared and divide it by x, and I get -11x. Multiply it back, I get -11x squared, -55x, change my signs. I get 3x plus 15, and then 3x divided by x is 3. Multiply back. This is a little annoying that this is in the way. 3x plus 15, change my signs. That gives me a remainder of 0. So whether you use synthetic division or you use long division, you should get that same quotient. Yep. Okay, now let's see if we can factor it. So far I know the z of x polynomial. Let's go back to this color. It's kind of pretty. don't think that's the right color. Oops. I think I had a purple. This one. Yeah. We know it has a factor of x plus 5. And now we know it has a factor of x squared minus 11x plus 3. So now we want to think about, can we factor this expression? So let's see. I'm just going to write it down again. This would be tricky tram, so I want to think about what multiplies to 18 and adds to negative 11. So pause the video for a second and try to factor that expression. Okay, let's take a look at this. So I'm going to bring down the 6x squared, my first term. I'm going to bring down the 3, my last term. Right here and here. Now I want to think about factors that multiply to 18 that add to negative 11. So they would be negative 9x and negative 2x. You could have switched the order. You could have put the negative 2x first and then the negative 9x second. So now let's factor this by grouping. So here my GCF would be 3x. This is going to be 2x minus 3. Here my GCF would just be negative 1. This would be 2x minus 3. So I get 3x minus 1 times 2x minus 3. So I'm going to go back and I'm going to rewrite my polynomial, z of x, and say it has a factor of x plus 5. It also has a factor of 3x minus 1 and 2x minus 3. Make sure I answered the question. I did factor completely. Okay, if you look a little bit further down in your notes, there's a QR code practice. So I want you to give a few of those a try if you still have a few minutes left in the class period. Have a good day, everybody, and I'll see you tomorrow.